session recorded. Awesome. So today is our day 7. We're going to talk about storage collections and storage staking in in near protocol blockchain, not Rust blockchain. Now, for those of us who've not yet settled on an idea you're going to sort of work on as your demo project, then please do so as early as possible. If you don't have a project idea, you can as well share with your colleagues around and see if they can sort of give you an idea on what to work on. And as soon as you're comfortable working on your projects, then please go ahead. So in this session, we're going to need the tools listed there. So these are basically the tools that we sort of installed in our previous session, that is, and we've been using them up to this point. And here's basically what you're going to cover. So we're going to walk through a simple smart contract code. So basically, okay, we're going to write a smart contract code to do with the the storage collection. And in that particular code, we're basically going to look at the NEAR SDK's collections module. The collection modules avails to us various data structures that we can use to persist our data on blockchain. And guys, by persisting data on blockchain, in this case, you're able to sort of store data on the NEAR blockchain. So it's going to act as a database. Now, we're basically going to focus on 2, but there are quite a number that we're going to look at. So they're quite a number, but for this session, we're just going to focus on these 2: lookup, map, and vector. So we're also going to talk about storage staking, okay? And yeah, that is it. So let's get this going. So I'll just share something right here. Okay. So let's share this first. So this is the screen viewer, and I'm basically going to open up a new tab. Then let's search for NEAR docs, NEAR documentation, and right here, there we are. So we click on get started. Let's have that load as well. So I'm basically looking for the storage concepts. So we go under concepts, and it should be somewhere, data storage on NEAR. And maybe I can share this with us as well in the chart. Yeah, so that is the link. Now, all data stored on NEAR blockchain is done in key value pairs. So that is basically using the data structures you're going to look at. Now, these data structures are availed in the 2 programming languages that NEAR supports, that is the assembly script and Rust. So the first part is basically talking about the assembly script or these data structures on the assembly script. So I'll just keep that and get to the section that is talking about these on Rust. So now where was that? Yes, right here. So maybe I can just share this with us in the chat as well. There you go. Now, sorry. Come on, this thing is not closing. Awesome. Now, here are some of the data structures that NEAR blockchain avails to us that we can use to persist our data on blockchain. So this table really gives sort of some information about the data structure. So we have vector, lookup set, in an ordered set, lookup map, an ordered map, and tree map. So we're going to see what these basically mean. Now, in the table, I really hope you can see these guys. The table illustrates the data structures that are iterable. That means you can look through their content or their keys. So they're basically iterable. And the data structures that you can as well clear all values that are contained within them at a go. Remember, that is very that could really be expensive in the near blockchain. So you really need to take note of that while implementing such a functionality. We also have those that preserve insertion order and the range selection. So vector, as you can recall in our previous sessions on Rust, introduction to Rust, where we talked about the arrays, that is the fixed size array and the growable array, in that case, the vectors. So this vector is basically similar to what we talked about in introduction to Rust. It's only that this persists its data on the blockchain and you can iterate through its element. You're going to see how to do that. Now, lookup set is not iterable. An ordered set is iterable. You can iterate through its keys and the content. Lookup map is not iterable. An ordered map is iterable, and tree map. Now, if you're a fan of algorithms, I know you're familiar with whatever is going on right here. So big O notation values in the chat below describe the time complexity of the various collection methods found in the near collections that we're going to talk about. So these are basically telling us sort of the amount of work done while performing various operations within these collections we're going to talk about. Now, here's the cost of accessing data in a vector, the cost of of inserting data into a vector collection, deleting data, searching data, traversing the collection, and clearing the collection. So all these is available to you guys. You can follow the link I've just shared with you and read through all these and basically what they mean. Then down here is sort of a summary of gas consumption while performing these operations in this table. So this is basically an overview of what you're likely to spend as gas or a transaction fee while performing those operations. So these, from a developer's point of view, should give you a clear understanding while you're coming up with your projects or while you're working on a project, sort of to be able to choose well the kind of data structure or the kind of collection you're going to implement for your particular application, so that you don't have to spend a lot of gas while performing certain operations. So there are data structures or their collections that are better fit for certain data storage or certain operations within your applications and all that. So these should really be of help to you. Now, we have vectors that implements a vector or persistent array, and you can iterate through using the index, and you can also use a following map index. You can map an element using an index. A source code has been availed, so if you just want to explore more, that is to direct you to a GitHub account. Sorry, yeah, it will basically direct you to that. Then if I can get back to my tab, it also avails the implementation. So basically the Rust implementation of that particular collection, okay? And you can always read through all these. So you're going to know the kind of methods that are available to you. So basically how you can interact with a vector object on the near protocol blockchain. So all that, you can check the length, you can check whether it is empty or not. You can initialize or create a vector object using that particular function. And all these methods are all here for you guys to read through and really know what's happening within that collection. I've just shared the link in the chat, so you can just go through that. Now, that is it about the vector. So we're going to talk more about vectors in our implementation when it comes to how we can basically implement that in terms of code. Then we also have lookup set. It's also a collection that is available to you as a developer. It implements a persistent set without iterators. So you can't loop through the content in this case. So you cannot iterate over the keys, and it is more efficient in read and write operations. And all this information is available to you. So we also have an ordered set. We have lookup map, what we're also going to look at. This one implements a persistent map. So basically a map data structure. Then you cannot iterate over its keys. So you can't simply loop over the keys of that particular data structure. It does not preserve order when removing or adding values to it, right? And it is efficient in a number of reads and writes. And here's an example on how to add data to this particular data structure. So here's a simple function. So this is basically a wrap function that is wrapping up everything. But here is the actual implementation on how you can add data to this particular collection. So lookup map.insert. So we're using the insert method, and we sort of specify the key that we're going to store our value under or against. So that is basically what's happening there. To retrieve that data we just stored, we're going to use our merge statement to achieve that. So we're basically going to get, so lookup map.get, in this case, we're using a get method, and you're passing in a reference to the key that we used to store the value against. Then this is going to return an option, an enum, the option enum, in which we have a sum, to return a sum object. Let me call it that way. If the operation was successful, however, if nothing was found, then it will just return none. So in the case that something was found, then we retrieve the value from this particular function, and we can use it. We can either return it as they've done it right there. We can perform some basic operations with it within our function. And if nothing was found, you can as well do some operations. And yeah, the SDK source code is available, the implementation as well, and all that. So you can always read through all these. I've shared the link with you guys, and it would really be appropriate if you can go through this documentation to get an in-depth understanding of what these data structures are doing. Now, at this point in time, I'm just going to share our project, the project we created in our previous session, that is yesterday. Then we're going to pick it up from where we left. Now, right here, if you can just allow me exit my terminal for now, then I just increased the font. I'll just close some of these tabs. Just a minute, guys. so that we can proceed. Okay. So I really hope you guys can see that. Okay, so thank you. I'm really having unstable internet, guys, so please forgive me if I don't share my video. Now, we're going to pick it up from where we left yesterday. Let's just do this quite fast. So we're going to talk about the collection or the data structures we're going to use to persist our data on blockchain, or the near blockchain in this case. Now, the very first thing we're going to do, let's first talk about lookup map, right? So, or we can talk about vectors, something we're already familiar with. So let's begin with vectors, then I'll go to lookup maps. Now, we'll just pull this from the near SDK. It should be under collections, right? And then in this case, you're looking for vector. Great. So we just imported it within our project. Now, the next thing we need to do is to indicate somewhere within our struct or class that we're going to use this particular collection to store or persist our data, okay? And at this point, I'm just going to do a new instance variable right here. We can call it, let's call it names. So this is just for demo purposes. So names is going to be of type vec, and this one is going to store values of type string, okay? So that is basically how we do that. Then let's have the comma in place as well. So you realize that in line 18, we have our function complaining because we have something that we've not initialized. So we'll just bring it in over here. So let me first of all sort of make this presentation, right? Then you can have the names. And we're going to initialize this to a vector. Yeah, we can initialize that to an empty vector. So that is we're good to go. So we've just we've included the names vector, and we've also initialized it. So that's good to go. So we're just going to create a function right here. Let me put it on top somewhere here. So we're going to work on a function that is basically going to help us add some values to our vector, and also do a function that is gonna get a value from a vector, and another function that will try and remove the value we just added from our vector, okay? So let's get started. So the very first thing we need to have right is a public function. In this case, we can say save name. Sorry, save name. Before Rust fights with me on using camel case. So save name is basically going to accept a string. So basically a name, okay? So this should be of type string. Then after accepting that particular name, we need now to store it within our vector. And how do we do that? Let's have a look. Awesome. So we're gonna do, so the very first thing I think I was forgetting this, is we need the self in place. And in this case, we're going to mute our object. So we're going to do self. Then we're going to get the names vector. And in this case, we're going to do what? Push. So basically, we're going to push an element to our names vector. So in this case, the element we're going to push is the name element. So that is that, right? After pushing the name, we can, what should we return in this case, guys? Whether it was true or false, right? Let me see if there's a, no, this doesn't have anything of that sort. Okay, so we can basically return the name. Let's return the string we just a reference to that string actually. A reference to the string we just added. So in this case, we need to sort of return the name. Okay, so that's not working. Okay, let's return a value, a Boolean value. Once this is done. So this is basically to indicate that, hey, what was done was successful, okay? Again, this is just for demo purposes. There are numerous ways you can always do this. So that is basically a function that is going to help us push data to our persistent collection. Then we're going to have another one that is going to retrieve. So in this case, get, okay? Let me see if I can get this right. Get names. So to get names, just get rid of this first. So to get names, we're not going to have any parameter passed to us. So we can just get rid of that. We also need an immutable version of that. Can get rid of that as well for now. Now, for us to get name, we're going to have a reference to our names vector. Then you're going to sort of iterate through it, right? So in this case, we can use a for loop. So for name in self.names iter. So awesome. So right here, I'm just going to sort of come up with a simple array that is going to help us hold the information we're going to retrieve from our array for us to be able to return that particular array, sort of a collection of the data we're going to have retrieved. So right here, let me just do let mute. Let's call these results. And results is going to be of type vec. Sorry. Results is going to be of type vec string. Right here, I have the vec initialization, just like that. Okay. So inside here, I can simply do results dot push. And in this case, I'm pushing the name. Okay. Let me push a reference to that name. Okay. Yeah. So that is how we go about that. Then after that, I expect to return this particular vector. So we're going to return a vector of type that. Sorry guys for that. Then down here, just pass in my results. Yeah. So yeah, we can choose to go with that. Awesome. Now I think I need to have this as vector. And vector is going to be initialized as okay. Let me just get these right, guys. So this is going to be vector. Then we're going to invoke its initialization function. And we're going to pass in, now this should be a byte. So you're going to pass in sort of a name that is going to uniquely identify this particular vector we are creating on the near blockchain. So we can just call it name. So N, I think N should do. So we can just, that is how we go about that, guys. I confused it with the vector in the Rust programming language. So this is how we imported it. This is how we initialize our instance variable, and this is how, sorry, we declare our instance variable, and this is how we initialize it. So please take note of that correction right there. Then over here, we need to push, I think, a reference, not the string itself. Yeah, we need to push a reference of whatever we are passing in. Then these should now let us return the name. Great. Then while getting the names, now here we use the normal vector of the Rust programming language, and we accessing all the information from our persistent vector. That is how we do that. And we push the results to our newly created vector. Then let's see how we sort of can delete or remove some function, sorry, some elements from our vector. So in this case, we're just going to remove name. Now to remove a name, we'll have to pass in the index number, I think, that we want to remove. So this should be is it I32? We're going to find out. Let's find out what this is. Now, to remove an element, we're gonna access a mutable version of our object. So we just add that. Then we do self.names, right? Dot. I think it should be removed. We don't have a remove. We should have a pop. Awesome. So pop is basically going to remove the element that was added last to our array, because the vector data structure is going to sort of store our elements in a stack. It's going to store them or take the form of a stack to store our elements. So when we run self.names.pop, the very last element from our stack is going to be removed. So in that case, last in, first out. If you're familiar with that concept, last in, first out, that is the stack collection. So we don't even need to pass in the index. So that is basically how we go about that. Then I'm basically going to build this. Now we already have our build script in place. So this is what I'll basically fire up. So scripts.build, and that should be able to run. Okay. Oh, sorry. I need to seed into contract. Then we need to run this from contract. So scripts build.sh. So that should go ahead, build my smart contract. So let's really hope this works. Awesome. So that was done. Then I'm going to deploy my smart contract. Can a function return more than one value in Rust? Yes. I think I did this yesterday. You can basically use the tuple primitive to achieve that, or you can come up with a separate struct or class that is sort of going to, bundle all the data you want to return. I just return it at a go. So that should be able to work, but you can't return it. You can't return a Boolean, a U32, and a struct at a go there. The way you specified it, Alan, in the chat. So that cannot happen. You sort of have to use what's already in place, any primitive or a struct object in that case, or an enum as well should work. So let's deploy our smart contract. Let's hope this works as expected. Okay. So let's hope this finishes successfully. Awesome, so that was done. So we're going to basically test, okay? So let's call one of the functions we wrote yesterday just to test that we actually deployed our smart contract successfully. Awesome, so that just worked. Oh my God, I'm doing some other operations down here. Okay, I didn't mean to do that. Okay, so that's fine. So our smart contract is successfully deployed on blockchain. So we're basically going to test what the functions we just wrote or added to our smart contract. So we're going to do, let me see if this is going to be a view function or a call function. So to save name, we need a name, and we're going to, so this should be a call function. So we're going to do near call, and we basically need the wallet address or the account ID where we deployed our smart contract, and the name of the function, in this case, save name. So that is what I just copied over there. Then our parameter our function accepts a parameter. And this is how we provide a parameter, guys. So I never covered this yesterday, so please be keen. So you realize we need a name. So I'll just copy the parameter name and have it enclosed in double quotes. Then give that colon and provide the value to this particular parameter. So you realize it takes a JSON object structure. So I'll pass on Destiny. Destiny, we're going to use your name today. Hope you don't mind. Then we're going to specify the account ID that is going to sign our transaction. In this case, I have an account that you're going to use, testnet, yto.testnet, okay? Awesome, so I'm just gonna save that. It already saved, autosave. Thanks to Samson. So I'm just gonna run this script file again. I hope I commented out, so let me just comment out this so that we just run this particular function and see what that is going to give us. So basically it should return to us the name Destiny. Awesome. So we just stored the name Destiny in our collection. So if I go ahead and add another name, in this case, I'm going to run this particular command again. And this time around, I'm going to run it with a different name. So let me just get, there's a very interesting name we'll have right here. Let me just use that right here, Daramola. So Daramola, I hope you're around as well. So let's run that. It should return to us Daramola. Great. So that is basically what happened. So up to this point, guys, we expect our smart contract's persistent collection to have two elements in the names object. Okay. So let's find out. So we're going to find out these by running another function that we definitely created right here. So let's get names. And to get names, we're basically going to read the state of the blockchain. So in this case, we don't need any parameter passed. I'll just do away with all that, guys. Then instead of a call, I'll try a view call. And a view call doesn't need to be signed. So our function call or our command is going to be as short as what you can see right there. So I'll just go ahead and run that. And you realize it returns to us Destiny and Daramola in an array. So this is basically the vector we created to hold our data. Okay. So that is it up to that point. The other thing we're going to do is, yes, Samson, you have your hand up. Please unmute.
Hello.
Hello.
Okay, we are talking about persistent storage. So you remember the contract we created yesterday for numbers?
Yeah.
So those numbers, were they persistent? Like, I think yesterday we left it at 1. When I come back a year from now, can I still retrieve that data?
Yeah. Okay. If you didn't, okay, in this case, if you look at our deployment script, you realize we are deleting the account first, then recreating it, right? So this basically interferes with the state of our smart contract, okay? But if we were just using the same account, if we never deleted it, then you should come several years later and find your initial work intact.
Okay, thanks. And I'm just curious, what about when calling the functions?
Yeah.
Is there a way to specify the contract? Let's say one contract has a certain, let's say a function call name, then maybe tomorrow I create another contract and it also has a function called call name. Yeah. Now, how will I know which contract I'm referring to that has that function?
Because while calling your functions, you're specifying the contract account ID right here. So in this case, this command simply says that, hey, we're going to call a function called get names, but then this function lives in a smart contract that was deployed at this account address. Now, if you're going to deploy the same smart contract, but in a different account address, then you're going to call the same name of the function, but in a different, so right here, you're going to pass a different account ID or wallet address where you deployed your smart contract. And maybe just to bring it to attention is that you can't deploy more than one smart contract in one wallet address or in one account ID. So that can't happen. So at any given time, a wallet address can only contain one smart contract. So that is where the difference comes in. So you can have the same smart contract with the same structure, but in different wallet addresses, and they'll still be able to run well. I don't know if that answers you.
Yeah, yes, thanks. I didn't know that fact that only one contract per account. That's why it didn't make sense. But now it makes sense.
Yeah, it's just one contract per account. That's why you realize that we are deleting it first before we can redeploy any changes to it. Yes, Philip?
Okay, so my question is, so after deploying these contracts on the testnet, can you actually view them on the actual testnet blockchain?
Yeah, actually, you can go ahead and run the functions I'm running right now. So go ahead and test this. Go ahead and run from your end the get names or any of these are we going to run from your end. So I'll just paste this in the chat. So you can just copy it as it is, as long as you have near CLI installed, then tell us what you get. Do you have near CLI installed in your machine?
Yes, I do.
Yeah, so please just run that and let us know what you get, okay? So this is already on blockchain. It's not running from my local machine. Yes, I saw another hand. Destiny?
Okay. Hello, sir. Can you hear me?
Yeah, I can get you.
Okay. So you just mentioned the next CLI. I installed it, and after installation, I had to use the command near -- version, and it's telling me that it's not recognized. I did it twice, it didn't work, and I did near itself. It didn't work, was not recognized. So I posted the error in the group. I don't know if you've seen it.
I saw it and I think I responded to the error. I don't know if you saw the response I gave.
No, let me just check it now.
Awesome. So I responded to that. Maybe you can just check it. If it doesn't work, maybe you can raise the issue again. So Philip, what did you find?
I can actually see them on my side. I can see the names, Destiny and Daramola.
Yeah, awesome. So that means this thing is not running from my local, it's already on blockchain. So anyone on Earth or anyone having an internet access on any planet should be able to get the same results. Okay. Awesome. So we're just going to proceed. So we were here. That was the get names function we just wrote. So we're going to try and remove one name from our list. So in this case, the name we added, the very last name we added was Daramola. So by running the remove function, in this case, the pop function of our vector collection, we should be able to remove the name Daramola from our persistent collection, in this case, our database, okay? So that is exactly what you're going to try to do right here. So I'm gonna have to sign this particular transaction. So I'll just copy the command I had previously, comment that out, and comment that. Then in this case, I'm going to do a near call, remove. In this case, I'm gonna remove name. Let's see if it requires any argument. That doesn't. Awesome. So we can just do away with the contents of our JSON object. Then we have that signed. And we go ahead and execute. Let's see what that is going to return to us. So it's returning an empty string. Why? Because we never specified or returned anything from the function. Okay, so you realize it's a void function. So that's why we sort of have an empty string over here. So if we get the values of that particular, or get names again, let me just comment this out. So we're going to get names again and see what is going to be returned to us. So you realize we just have one element or one name. So in this case, Destiny. So Daramola was popped out or was removed from our collection. So that is basically, guys, how you go about that. Now, these call functions I'm doing, like the one we did over here, you realize there are some links attached to it. So this link, the Explorer link, is basically where you can go and check what happened. It's sort of a transaction receipt, okay? So using this particular receipt, what I just highlighted, this receipt, you can basically go to NIA Explorer. So let me just copy this and reshare my browser. So in this case, was it that? So let me see if it is this. Yeah. Okay. Not these really. Yeah, these. Then I'm going to go to Explorer. So in this case, NIA Explorer, okay? So explorer.testnet.nia.org. So over here, I'm just going to paste that particular receipt address. Oh, sorry, it's not done loading. So I think we are good to go. Awesome. So I just searched for that receipt, this receipt hash code that was returned to us. And you realize it gives us a detailed information on what happened on blockchain. So we basically attached 30 teragas and we used 5 teragas out of the 30 we attached. And then in this case, we never returned any value. So no value was returned to us. So that's why we have, so here we have whatever arguments we gave. And we didn't have a return value. So that's why you can't see any details on that. But the method we called is listed right here. And the contract we called was under this address. So all the information is right there. Okay. Awesome. So maybe you can just proceed from our IDE again. So guys, that is it about the vectors. That is it about the vectors. So right now, maybe if we can just clear that out. Right now, we're going to talk about the lookup. Time is almost gone. So we're going to talk about lookup map. So lookup map, I'm simply going to sort of redo, or rather, I'm going to make some changes to our counter code. That is the code we had in our previous class, so that we are able to persist the value we are storing on blockchain, like one of us was trying to inquire. So in our value, we can call these, what should we call? Let's call this count. And our count is going to be of type lookup map. And we're going to import these from the near collections module. Our lookup map is going to take a key of type string. Okay, so guys, I really want you to be keen on how we are going to sort of structure this code. Initially, anyone would increment this value of our counter. Okay, so you simply call this particular smart contract, and the value would be incremented by anyone. So in the code I'm going to do right now, only the signer, so in this case, you'll have to log in with your wallet address before you can increase the value of this particular counter. But then this value will just reflect on your, this value will be related to your wallet address, okay? So if I incremented my value to 10 and someone else incremented their value to 7, if I log in, I'll see the value 10. And if they log in, they'll see the value 7. Okay, so that is the basic idea we're going to implement at this point. So our lookup map is going to take a key of type string and a value of type U32. Awesome. So, okay, what's happening right here? Okay, let's hope that is going to, want to see how to debug that. So let me just put this over here. And we're going to initialize this. So we're going to, this is how we initialize the persistent storage, different from the the Rust data structure. So this one is going to take a byte string, and this is going to be our counter. So we can just name it C. Then let's see anything else we need right here. Okay. So after that, I'm basically going to sort of change the code. It doesn't implement the debug trait. Okay. So which one should I use right here? So it seems that I can't use the primitive data types over here, guys. So I'll just, let me just use these from near. Let's see how this is going to. We also can't use this. How about string? Okay. So let me just get rid of this particular, this macro I'm using here, the debug macro, since it's causing us a lot, so that don't fight with the compiler too much. So I just remove the debug macro we had, then we are now good to go. Awesome. So we've initialized that and we've declared it up there. So I'll just make the changes within our function. So I'm not going to touch the names, any functions to do with the names. I'm just going to touch these. So to read the value, I'm basically going to access the count, any instance variable we have. Then I'm going to, so in this case, like I said, we're going to sign, right? All these transactions are going to be signed. So in this case, we're going to expect a wallet address to sign the counter transactions. Now, to do that, before we can even read our count value, we need to capture the wallet address that is sort of signing this particular transaction. So in this case, we're going to get that, we can call it signer. And like I said, we're going to use the env module. And from there, we get the signer account ID. So that is how we retrieve the wallet address of whoever signed this particular transaction. After that, we're basically going to match. And whatever you're going to match is the count instance variable. And we're going to try and get a reference to our signer. So we're trying to get some value from it. So if it returns with a counter, we're going to name that counter. In this case, we're simply going to return that particular value, counter, okay? If that was successful. However, if nothing was returned, then simply return 0, okay? And in this case, we are returning a U64 value. So that should be able to address the error. So that is how we go about reading a value. So in this case, you realize you're reading your own value, not any other person's value, okay? Let's go ahead and try and decrement this particular value. So like I said, we first of all need to capture the wallet address that is signing this particular transaction. And after that, we just need to go ahead and get the value. So in this case, U64, sorry, in this case, the counter, we're getting the counter of type U64. And we're getting this from the count collection. And we're gonna get, okay. So I'm gonna represent it this way. We're going to get some counter. And we're going to get this from count.get. And we're gonna pass in the signer wallet address. Then from there, if we actually got the value, so in this case, the counter, let me see what's happening here. Expected boot, but then found that. Okay, yeah, so that is how we go about that. So in this case, so this is similar to the match function, guys, the match function up here. It's only that I'm trying to shorten it. And this is how I shorten that. So I'm saying if let some counter value after retrieving it from this particular object. So any value we're going to retrieve from this particular object is going to assign to this variable right here. It's going to take this particular object, the sum object. And then if that was successful, then I'm simply going to, let me copy this. So if that was successful, if that was successful, so if self dot value, in this case, if counter, okay, we're going to check if counter is greater than 0, first of all. If it is, Then we're going to do counter, control V, counter -1. So we decremented the value by 1. And after decrementing this value, remember we have to persist the new value decremented on the blockchain, okay? And to do that, we're going to store it again on the blockchain. To do that, we're simply going to do self.count object, and you're going to do insert. This should be insert, right? Yeah, insert. So we're going to insert. Remember, the key is whoever is signing this particular transaction, and the value is going to be the counter. This is going to be the counter. So this should be actually be a reference to that. So a reference to the counter. Awesome. Now, by this particular line of code, line 64, basically persists the new value on blockchain. So this way, after years, we are able to get the same value we were talking about, or we left on our blockchain, okay? So let me just get rid of this. So that is the data, the code we had initially. That is the code we had initially. Okay, so yeah, after that, remember we need to return something right here. So this should be of type U64. And at this point, we're basically returning, we are returning a reference to what? To the counter. This should be not a reference, but a real value. Yeah. Oh God, what's here? Okay. Awesome. So let's hope this works. So else, that is if it didn't get any value from this, but from our storage, the account storage, then let's just return 0. Okay. So that is if we never found anything. So instead of, you realize here we used none. So this none case is what we are replacing with the else statement. So if none was found, then simply return 0. So that is how we go about that. So I'll sort of carry this. Let me just carry this code to save on time to our increment function down here. And I'm going to replace this U32 return type with U64. And the very first thing we're going to do is retrieve whoever is signing this particular transaction. So that is how we go about that. Then we first of all fetch for their record, if there's any record that is within our storage. So that is how we go about that. And then you realize right here, we're not checking if it is greater than 0. So we're going to remove these if statement over here altogether. Then after that, we'll basically go ahead and add, or rather increment. So counter plus equals 1. So we've just implemented the value, but then we'll have to persist this particular value on the blockchain. And how do we do that? Sorry, line 79 helps us do that. So self.count.insert using the sign our wallet address as the key and a reference to the new value of our counter over there. Then after doing that, we basically return that particular value. Why is this the case? Why is that the case? Yeah, so we return that particular value. Then if we never found anything, so in this case, we tried checking in our database, but then this value, this user doesn't seem to have stored any value within our database. So we just want to return 0. All right. Now, there seems to be some problems here. We have some type mismatch. I think it found that. Okay, why is this the case? Okay, so I had a colon after the return type, sorry, the return value. So for me to indicate that I'm actually returning it, I should remove that. Then this seems to cannot have a mutable variable counter. Okay, so it seems we have a problem up here. So we can just get a mutable value of that and also get a mutable value of our counter. So that should be able to fix that particular problem here. So let's see. So that is basically how we implement the map, how we can persist our data using the map data structure or collection on a near protocol blockchain, guys. Okay. Again, I'm going to push this code on the GitHub, and you'll be able to sort of go through this at your own time to understand it better. So I'll just go ahead and run our build script first. So let's hope this is going to build successfully. Awesome. And after that, I'm simply going to run the deploy script so that we have this deployed or updated on the blockchain. So let's hope this also happens successfully. So that happens successfully. Awesome. So after that, we already have our functions or our smart contract updated. Now to test that actually our smart contract is actually running successfully, let me try calling this method. So it returns an empty. So that is great. So our smart contract is in the right state we expected it to. So right here, now all these are going to be called functions, guys, because of the data we are retrieving. So we need them to be signed. So we're going to call, what was the function again? So we first of all can try read the value, right? Let's try reading the value. So to read the value, it doesn't require any parameter, I can recall well, but then we'll have to specify the account ID or the wallet address that is going to sign this particular transaction. So in this case, I'll use yto.testnet for now. So that is what is going to sign this particular transaction. So let's go ahead and run that again and see what is going to be returned to us. So we should get a 0 actually. Awesome. So that is definitely what we got because we've not incremented the value yet. Now I'll just go ahead and sort of make that copy, but then this time round, we're going to try to do what? Increment our value. So before we call the decrement, let's call the increment function first and see what that is basically going to give us. So you remember our increment function is basically going to increase the value. Then we return the initial value we had. So awesome. So the initial value we had is 0. And we can't see any error. So it means that we should have incremented the value successfully. So let's test that by reading the value again. So let us just call this and see the value we are trying to read in this case. So it should return 1 because we incremented it. Oh no. So this just returned 0. It means we are having some we have some mistake within our code, guys. So right here after incrementing, we should be able to have a new value. Let me see if let's just create a new counter variable right there. Then say counter plus 1. Okay, then right here, basically pass this in. Okay. So we should have that. Let's try the same ideology over here. So instead of that, let's have these in place. Bring it in. Get rid of these. Then we pass a reference to our new counter value right there. Then we can as well make this other change we made initially right here. So we can basically sort of return that as well as a newly created value. Okay, that's great. So let's see if these changes are going to take effect. So to do that, we simply are going to build this again. Okay, then deploy. Let's hope this deploys very fast. Awesome. Then let's try and increment the value first before we, sorry. What did I do? So let's try and increment the value first. So we're gonna run that call. So this is still giving us 0. This is still giving us 0. Can someone see where the error is? It's still giving us 0. That should not be the case. Is anyone with a solution to this? Because right here we're incrementing the value and we are assigning it over here. And we're basically storing it right here. Okay. Okay, let me do away with the return tab for now. Let me just try and do away with the return type and see what this is basically going to give us over here. Okay. So may the else block be running? instead of the if. Yeah, it could be. It could be, yeah. Oh, by the way, that's true. So thank you so much. Thank you. Who was this? Samson, thank you so much. I think I was missing that bit. So we really need to make that correction first. Just do away with this first. So let's have that corrected. So in our increment, we're just going ahead and doing what? And returning the value 0. So in this case, if it is not going to get our wallet address within our database, there's nothing that is going to happen. So I think this is where we missed the point. Instead of returning 0, this is what we should do. Let's copy the code over here so that we first of all have, now we'll begin from 1 definitely. So we have 1 assigned to our new counter as the initial value. Then that is what we are actually storing over here. So yes, yeah, I think that was the catch. Thank you so much, guys. That is what. So if you're trying to increment, but then you don't have, you don't have any credentials within our database, you should be able to create it to create a new one or a new credential for you. So that is basically what we're doing there. Then in our decrement, if we don't get your value from the database, what should we do? We should just return 0. So I think this one should work well. That should be able to get us going. Awesome. Yeah. Thank you so much, guys, for that. So let's build this and see what is going to give us. So deploy. And right here in increment, I also want to return the new value, the new counter value, not the older one. Not the older one. So right here, the new counter value, not the older one. Oh my God. Why did I make the change? So it was here. So over here, while decrementing, we need to subtract 1 and not add 1. Yeah. So after subtracting 1, we get that right. Then, okay. Oh God. We have this over here. Over there. This can take 0. It should be mutable. And it's gonna take type U64. Then down here, I should just be able to change that value. And instead of returning that value right there, let's have it down here. Great. So that should be able to work well. How about here? Everything seems great. So let's just rebuild this again, guys. There are some changes I made. There's some changes I made to our code. So let's build that again. Then deploy. Deploy. And that was done. Great. Took some good time. Now, we're going to try and not read the value, but increment the value first. So let's just call our call script file. So that now should give us a 1. Nice. Thank you so much, guys. We did this. Now I'll comment that out, or I'll just, okay, let's increment it for the second time so that we have the value to be 2. So you realize that the value that is going to be printed is 2. Awesome. Now, if we try read the value now, if we try read the value, it should give us 2 in our terminal by performing the read value function. Yeah, so that is 2. So now it's working quite perfectly. Now let's try and decrement the value, right? Let's try and decrement the value. Let's see what that is going to give us. So I'm just going to copy our function decrement over there. Where do we have also? That is the name. So that we don't have any misspelling within our name. So that is it. So I'll just go ahead and call. What happened? Call. So that should decrement our value. Yeah. So it was decremented and the new value is 1. So if we try and read the value again, so instead of 2, this time around we should have the value 1 printed on our terminal. Great. So our smart contract is operating as expected. Now, if you are writing some tests to our smart contract, we would have been able to see that or what's happening, figure out the problem or the issue. Now, at this point, before we can wrap up, please. Yes, Destiny, we did it again. Yeah, so I'll just request for a bit of your time, guys, to explain the last concept, that is storage staking. Now, what is storage staking? Assume that you're coming up with a social media platform where people are going to post in, you know, comments or their daily feeds over there. So they're basically going to store information within your smart contract. And like I said in our previous sessions, that any data you store on the Near protocol blockchain, you have to pay for it. You have to pay for the storage cost. You have to pay for the space occupied with that particular data, even if it's a string or a number, any kind of data you're going to store. You definitely can't store an image on directly on the Near protocol blockchain. Now, if we're going to have 1 million users, but then your smart contract only has 1 Near in its account, then you can be sure that particular functionality is going to fail. Not because your smart contract has errors or bugs in its source code, but because it doesn't have enough funds to cater for the data that is stored, that the smart contract is going to store. Okay, so this means if you're going to store, let's say 100 kilobytes of data on the Near protocol blockchain within your smart contract, then you'll have to part with 1 Near token from your smart contract account. Okay. Now, if we just, okay, if our naming vector. So if we are just to leave this particular functionality as it is, then our smart contract can easily be interfered with, or it can easily be spoofed. The denial of service attack can easily be done on this particular smart contract. Why? Because we're just storing names. There's nothing else we are doing to it. So it means that the owner of the smart contract is the one going to cater for the storage of all these strings, of all these names within this particular collection. Now, in order to restrain that attack, or in order to prevent such an attack from happening to a smart contract, we want the users who are going to store any data within our smart contract to cater for the storage cost. So that is the concept of storage staking, okay? You sort of let the users pay for the amount of storage their data is going to do what? The data is going to sort of occupy on our blockchain. So that is exactly what it means. Now, I'll implement this within our counter and see how we can let users now pay for the storage cost and not us paying for that storage cost, or the owner of the smart contract paying for that particular storage cost. Now, for you to be able to pay for that particular storage cost, we do it in our increment function, right? Because the decrement is basically, okay, we'll do something else in our decrement. Or should we do the names? No. Let's do it here. Sorry. So in our increment, after getting the wallet address of that is signing this particular transaction, the next thing we want to do is check the storage used before doing or performing any other operation within this function. So we want to do current storage. And we're going to get this information from our env module, and should be something to do with storage, storage used. Okay, so storage used is basically going to give us the amount of storage that is used before adding any information to the blockchain. Okay, and after we add right here, okay, right here, after adding some data to the database down here, okay, we're going to check, we're going to basically have something like this over here. So you realize at this point you're inserting some data to our database, right? So it means that you're going to interfere, or rather we're going to either add. So if the user is doing this for the first time, then they're basically going to use what they already paid before. No, if they're doing it for the first time, they're going to have to pay for that storage space. But if they are doing this for the second time, then they may not really have to pay much to that effect. So in this case, instead of current storage, you're going to check for used storage, okay? Then to get the amount, let's call this initial storage. I'm running short of names here, guys. Then we call this current storage, right? Then right here, let's name this variable used space or used storage to make our naming sort of consistent. So our used storage is basically going to be the current storage minus the initial storage. So this is basically going to give us storage in bytes that this particular operation used, okay? So after getting the storage in bytes, we want to get the payable storage cost by the user. So to get this particular value up here or somewhere, let's do this over here. So I'm first of all going to get the price per storage unit, okay? So the price chargeable per storage unit. Think of it like NIA protocol is going to charge you 1 NIA for every 1 MB you store on blockchain, okay? So that our unit price is going to be 1 NIA for every 1 MB. So if you're going to store like 50 MBs, then you're simply going to do 50 multiplied by what? The storage unit, that is 1 near, for you to get 50 nears. Oh, sorry, 50 near tokens that you need to pay, okay? So in this case, we're going to check for unit price, storage unit price. So at this point, we can add storage unit price. And to get storage unit price, we do ENV, and that should give us storage byte cost. So this is going to give us the cost per byte. So the cost for storing a byte of data on the near protocol blockchain. Then to get the payable storage, I simply take these storage unit price times the used storage. Where's that? Over here. So that is basically what I need to do. So after doing the multiplication, that will give me the payable storage. Then I can just send that like that. Okay. Oh, let me see what it needs. Okay. Unit price is this. So we need to get, this is going to give us the balance U128. So we can basically do U128. So multiply. Checked multiply. Okay. Oh God, am I doing this right? Philip, you have your hand up.
I wanted to ask why we are using checkmal.
Okay,
checked
multiplication is basically going to help us so that we don't have an overflowing representation of bytes within our data type. So if we have a U128 data type, but then whatever number we're going to represent is sort of going to go beyond the stipulated bytes to hold that number, then it will sort of trigger a panic function. So it's sort of going to panic, or there's a way it's going to handle so that we don't run into that error. I don't know if you get the explanation behind that.
So, okay, yeah, it's a bit clear. Let's just finish. I see how it's gonna go.
Okay. So let me see. This should be from. Oh, I'm not getting these right. What if I just pass you direct inside there? Then do away with these. This guy expects a U128, but then we provided a U64 data type. So we achieve that by providing that into. Then yes, that should be able to give us the payable storage. And now I will down here wanted to do. Now after we have the payable storage, this is basically the storage cost we expected to pay, right? We need to check. So in this case, we need to assert, right, that we need to assert that the attached deposit. So this is how we find the attached deposit. So this is basically the tokens that the user attached while invoking this function on our smart contract. So we assert if it is greater than or equal to the payable storage, right? Let's try and do this out of these. So you can just call this attached deposit, then define it somewhere up here. So let's attached deposit equal to that. So this one is giving us a data type of U128, and this one is giving us a data type of option. Okay, now, so we'll have to sort of tweak this in order for us not to run into some issues. So I'm just going to do these right here. Then that, yeah, so this should be able to work. Then I'll just carry this inside of this function. Then I'll provide some space for us to be able to see this. So it returned an option enum. So this is how I retrieve the payable storage cost. Then if I get it, I first of all assert that the attached deposit is actually greater than or equal to the payable cost. Okay, so if that is true, then it means the user will have covered the storage cost for this particular operation. However, if the user attached more than we needed, so in this case, maybe this particular operation is only going to need like 1 year. Okay, so again, I'm using random figures just for us to get the understanding. So in case this operation is going to need 1 year for the storage, but then the user attached 5 years, then it means we need to return to them 4 years, right? Because we only used 1 year for the storage. Now, to be able to do that, we used what we call promise. Again, I'll be talking about promise in our cross contract call, so don't worry about that. So in this case, we simply pass in the signer. Where is that? Reference. So to the reference account wallet address, then you want to do a transfer. Now this should be transfer. Okay. I first of all need to get, I think, a variable, an object from this. So let mute, let's call this promise. Then do promise new, passing in the signer account address. Then after that, we simply want to come, okay. Okay. So after that, we simply want to come down here and say promise transfer. And then we specify the amount of funds we want to transfer down here, guys. Okay. So these should only happen if the attached deposit is if they paid more than what was expected of them. Okay. So in this case, we'll have to first of all check if what they paid was actually more than what we expected. So if, so we can call this excess, right? Excess. I hope that is the spelling. So if the attached deposit minus the payable, why can't I get this over here? Attached deposit minus the payable deposit is greater than 0, right? Let's make things a bit clear. So this is let's call this surplus. So surplus is basically going to be the difference of the payment. So right there. So I simply carried that over there, guys. I hope I didn't confuse us. And I'm going to check if the surplus now is greater than 0, in which case we return the surplus. Else, we're going to return 0. Okay. Sorry, else, yeah, we return 0. Yeah, so that is the shorthand of if in Rust. If surplus is greater than 0, return surplus, else just do 0. Okay. Then we're going to check now. So we first of all are going to assert, in this case, let's assert equal. So we're going to assert that our excess is equal to, sorry, we're going to assert our excess is not equal, so assert NE not equal to 0, right? So after making that assertion, then that is when we can now go ahead and do what? And transfer the excess. Again, you can always tweak these guys to your preference, but this is what I mean by storage staking. So you realize that at this point, the user, and we've added a lot of code to our increment value. I really hope you guys have not got confused. So this is basically how a user can stake for the storage. So they basically pay for the storage or any data they're going to store on your smart contract. Okay. Now I'll just copy this, and we're going to do this for just this one function for the sake of time. But if you guys, because I'm going to push this on a GitHub repo, you can just clone it and practice with it, and then see how you can go about it. So at this point, I'll just copy some of this code. So right here. So where did we begin this particular change? So somewhere here, right? And again, you can organize this into a function so that we don't have redundant code within your smart contract. So let me just copy that up to that point, Control C. Then I'll add it down here. I'll add it down here. So I just added the code we wrote in our if block. So if the user is not yet registered, we first of all insert their details within our database, like we've done right there. Then we check the current storage, then we get the used storage. Then we retrieve the storage unit price. And after that, we simply multiply that storage unit price with our used storage. And if all went well, we first of all assert that the attached deposit is greater than or equal to the payable storage, storage cost. Yeah, the payable storage cost here. If that is the case, we go ahead and remember, if they attached something less, then our program is going to panic, and every operation that was done previously is basically going to be rolled back. Okay, so if they stored a data, that operation is going to be rolled back, and that data will sort of be removed from the persistent collection. Then we check for any surplus, and if the surplus is greater than 0, we get the excess, and we assert that the excess, is not equal to 0. Then we do our promise, so we can remove the mute. Should be able to go. Yes, and just do away with the mute keyword right here. Awesome. So right there, we transfer the excess back to them. Then we basically return. So our assert, okay, at this point, this will make our program fail. In this case, if they attached exact payable storage cost. So instead of using assert statement, let's use an if statement so that we don't run into unnecessary errors. So we simply need to know if the excess is greater than 0, then we can just do this over here, right? Yeah, so these should be able to get us going. And let me just make this change up here as well to avoid unnecessary errors. Great. So that should get us going. So guys, I just made that change within our increment function. So that is the only function we'll modify for now. So I'll first of all build this source code and then deploy. Have that deploy. Then we're going to test. That is after everything is good to go. We're going to test if we can increment. So you realize at this point, you're not attaching anything. For some almost. Okay, so that was successful. Now we're going to run an an increment function of our smart contract, but then I'm going to specify the amount I want to attach. So in this case, I want to attach, let me attach 2 near. Then let's try and call this script file and see what that is going to give us. So we really hope for the best. Oh God. So we had something, we had an error. So what's the error telling us? Increment doesn't accept a deposit. So there's something we forgot within our smart contract. Now, since we are going to accept some tokens attached to this particular invocation, we'll have to explicitly specify that within our function. So like I said in our previous session, there's this macro availed to us, the payable macro. So this is basically going to tell the near blockchain that this function is accepting some tokens attached to it, to its execution. So that is where we that is what we forgot. But let's just try this for the last time and hope that all is going to work well, guys. I know this has taken too long. I'm really sorry for that. So let's hope this is going to work. Awesome. Now, if I try and now do the call, let's hope it's going to accept whatever near we attached. That it's going awesome. So that just did that, okay? So it, at this point, we paid for the storage of this particular value within the blockchain, okay? Now, if I can just try and call that particular function, but without attaching anything to it. This time around, I'm going to use a different wallet address because the other one already has some value. So this time around with a different wallet address. So let's try and call that again. Let's see if it's going to raise any issue. So you realize that this one raises an error. Okay. So in this case, the attached deposit was not greater than or equal to the payable storage cost. So in other words, we never attached any token that would be used to cater for the storage cost of our data on this particular smart contract. So that's why this error was raised. And if we try this again, but then this time around we attach some amount, 1 year, okay? So I'll just run this again with the same wallet address, Wajakaya testnet. So this time around, we should expect that to work because we've attached something that is going to cater for the storage, and exactly that is what happens, okay? So guys, that is it. That is basically how we can go about that. Yes, Destiny?
Hello, sir. Hello, can you hear me?
Yes, hello, Destiny, we can hear you.
Okay. I don't have a natural. I just want to ask for a favor. This one is a kind of stressful to my comprehension. I want to ask that tomorrow, please, our first 5 to 10 minutes, we should review this code, like go through a process step by step. I know we have access to it on GitHub, but I would like it that you do it, at least for me. And everyone else that their head is too hot now.
Okay, Destiny. I'm actually going to migrate our wishlist code to a smart contract. Then I'm going to implement this particular concept. So as we shall be walking through the code, you'll be able to understand the storage staking concept in our wishlist smart contract. I hope that will be okay, right? Destiny?
Yeah, if it's possible for us to understand and flow with while doing that, that's okay as well. But if you can just go to the code with that, it will be very, very, like, I'm so grateful for that. At least, because my head is very hot now, and I would like you to do it this night. The class has gone too far.
I know. There's a lot of code we've added right there. And I know some of us might have got confused. But again, we're going to upload this video. So if you get time, please go through it. But we'll be walking through our wish list code. So I'll basically translate it to a smart contract, make some few changes here and there. Then tomorrow we'll be walking through that code and see how we implemented it in the bare-bone Rust and how it is implemented on the blockchain, the near protocol blockchain, and how everything is executing. Okay, so I'll surely do that. Guys, we've really taken too long for this session, so please allow me end it right there. I'll still encourage us to take our assignments, assign challenge 1 and challenge 2, because tomorrow I'll be giving you challenge 3 as we proceed. Okay, so challenge 3 will be easy based on the concepts we'll have covered. So it's basically migrating your Rust code, the simple banking system, onto sitting it on the near protocol blockchain. Okay, so that is basically what you'll be doing. So thank you guys for coming. Let's meet again tomorrow. I can see someone. Okay, thank you, Collins. Yeah, it's too long, but worth it. Thank you so much. Sorry, did I lock any question out?